Back in the beginning of the course, we talked about the three states of matter: solids, liquids, and gases. For gases, we drew a picture that looked something like this. Here's the container, and inside you've got little molecules of gas, and they are zipping around, they are moving around at very high speeds, and they have a lot of space between them. So a gas is mostly empty space. And the molecules in a gas are fast moving. In fact, around room temperature, the molecules in air will move around the same speed as a rifle bullet. So they're moving very quickly. Now this is a molecular model of gases, and it explains a lot of things. In science, theories are for making explanations, and a model is an imitation of reality that's based on a theory. The theory that we're talking about here has a name. It's called the kinetic molecular theory. And it explains the properties of gases. For example, it's pretty easy to compress a gas. So here's an observation. If you take a gas and you squeeze it, it isn't too hard to do. If you put the gas in a little cylinder, so here's the gas in here, and you have a piston in the end that you can push in. It is not too hard to push that piston in, and that's because our model says you're squeezing out the empty space. And it's easy to do that. So it is easy for you to just push the gas into a corner. You're only making the empty space that they have to move around in a little bit less. Now, when you do that, you'll notice that the gas pushes back. So a gas exerts a sort of pressure, which we'll talk about in the next video a little bit more. Where's that pressure come from? It comes from the fact that you have fast-moving molecules, and they are beating against the walls of the container, and they would be beating against this piston. So as you pushed it in, the gas molecules colliding with the piston would be pushing back, and you'd feel some resistance there. So gases exert pressure because of the force of molecular collisions. That's the explanation for gas pressure. The more gas that you force into something, the more pressure you're going to feel. The more it's going to press back. And that's because, again, the same explanation. If you've got more molecules in this box, they're going to be able to have more collisions on the side. So they're beating, there's more of them to beat against the side of the container. And you'll see more pressure if you force more gas in there. Gases will completely fill their containers. And how come? Well, these gases are in constant motion. They will be constantly moving around, colliding with the walls, and they will explore every corner of this container. So they will not just sit on one side of the container or on the bottom of the container like a liquid would or a solid would. They will be everywhere in the container. Now, if you take two gases, there's a gas over here and a gas over here, gas 2, and you got a wall between them, and if you remove the wall, the gases mix, and they mix pretty completely. So the air is made out of oxygen and nitrogen. And the oxygen and nitrogen is mixed homogeneously. The concentration of oxygen is pretty much the same everywhere in air. So gases mix easily, and suddenly they mix fairly quickly. So that again is because the gases are made of moving molecules, and the molecules from gas 1 can go into this half of the container, and these molecules can go over there once you remove the wall. So we can explain a lot of properties of gases using this kinetic molecular theory. Here's another one. If you've got gases in a hot container, they have higher pressure. You know, if you look at the side of an aerosol can or a shaving cream can, it tells you do not incinerate. Don't throw that can in a fire. And the reason is that if you throw a can into the fire, the pressure inside is going to build up to the extent where the can explode. Why does that happen? This has to do with the fast-moving molecules again, but higher temperature leads to faster-moving molecules. And if you've got faster moving molecules, that'll be more collisions and more pressure. Now, this kinetic molecular theory is actually a mathematical model. You can do some math with it, and you can figure out exactly how temperature and pressure are related. And you can also relate the average molecular speed with the temperature fairly easily with this kinetic molecular theory. We're going to come back to this later on in the next worksheet and talk about some of the predictions that the kinetic molecular theory is going to make. I would like you, what do you get out of this? I would like you to be able to take observations like this and explain them with the kinetic molecular theory. And this is going to form the basis for many of the calculations that we're going to do in the rest of the worksheet.